All right, so today's video is the explanation of the birthday polynomial project. I know the video looks a little bit different, but that's because I have to be a little bit creative with how we're going to do this since I want to show you multiple screens. So the birthday polynomial project is basically going to be a polynomial based on your birthday. So I'm going to go over here, over to the side and kind of show you a couple of things. Our birthday polynomial is going to be based off my birthday. So, for example, my birthday is July 17th, 1982, and automatically you're going to be like, oh my God, how old is he? So let's see, July 17th, 1982. I'm going to write it the legal way. And when I say the legal way, that would be month, month, day, day, year, 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 year. Sorry. So if I said July 17th, 1982, because it's July, that would be 7, but you can't just write 7 because I need two of these things. So it would be like 07, right? So there's July 17th, 1982. Now this is for my birthday. You would be using it for your birthday, but my digits are 07171982, okay? Now that we have our digits, now I'm going to construct my polynomial. Everyone's polynomial is going to be based the exact same way, but eventually some of these numbers might start getting deleted because if there's a 0 in the front, we're not going to use them. So everyone is going to start with an x to the 7th, all right? So let's see. This is going to be, I'm going to put blank x to the 7th, blank x to the 6th, blank x to the 5th, and we're going to keep going all the way down until I get to my constant. Blank x to the 3rd, blank x to the 2nd, blank x to the 1st. By the way, x to the 1st is just x, okay? And then blank, where you just have a constant number, it would technically be x to the 0, but that x to the 0 kind of goes away and you're just left with a number, all right? I'm going to go ahead and start substituting my values. So I'm going to put, my first one was a 0. You see this first number. I'm just going to start substituting my numbers into this one. And so I have 0x to the 7th plus 7x to the 6th. In fact, I'm going to put all these pluses on these. So plus 7x to the 6th plus 1x to the 5th plus 7x to the 4th. Again, I'm just dragging these numbers in here. Plus 1x to the 3rd plus 9x squared plus 8x plus 2. All right, so that is a very, very long polynomial. However, some things do start happening. I want you to notice that I have 0x to the 7th here. Therefore, because I have none of them, I'm just going to go ahead and cancel that. So I'm actually going to start with the 7x to the 6th. Again, this one goes away because it's a 0. For you guys, I'm assuming a lot of them are going to start going away because you have that double O, okay? And then right here, this is 1x to the 5th. I'm adding 1x to the 5th, but we don't need to write 1x to the 5th, so I'm just going to write plus x to the 5th plus 7x to the 4th. Again, I don't need to write 1x cubed. I can just write x cubed plus 9x squared plus 8x plus 2. So this is my birthday polynomial. It represents the July 17th, 1982 date that we were talking about earlier, okay? Now that I have that, we are going to graph it, okay? So let's see what our graph would look like. It's actually right here, okay? I took the time to save it. And if you look at my birthday polynomial looks like this, okay? Now, honestly, when I looked at this, I'm like, well, I'm not sure if I want to keep this because it doesn't look interesting enough. So what you're going to do is you're going to play with these pluses and minuses, right? Right now, they're all plus, 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 plus. But notice if I take one of them and I change it into a minus, like all of a sudden my graph looks a little different, okay? You get to play with the pluses and minuses as much as you like, okay? And I've already spent a lot of time playing with these, so I'm going to turn this one off. And I'm going to show you the one I came up with. The one I liked was this one. All right, notice I have a positive, then a negative, negative. How did I end up with this? Well, I just kept playing with stuff until I liked what I saw. I'm going to zoom out a little bit. Now, this is pretty good. I'm actually going to make, I wish this was a little wider though, right? So let me show you a couple things. Number one, if you were to graph yours, you might end up with something that looks like this. Actually, go back to the original one. The original one looked like this. But I like this. I just want to zoom out a little bit. So I'm going to scroll out And this looks kind of like what I want, but this is too squished right here, right? So what's happening is I have too many x values. See that my x values go from -25 to 30, and I really only want the x values to go like from here to here. So maybe for like from -4 to 4. So I can change the way that looks by changing the graph settings. So I click over here, and my x values, I don't want to do all this. I'm going to go from like -4 to 4. So let me change that, -4 to 4. And now I got a much more interesting graph and something that kind of fits what I want it to be. Now, ideally, what we're going to do is we're going to try to come up with a graph that, number one, I can come up with a really, really cool picture about myself that I can tell a cool story about. Okay. So, what the heck am I talking about? Well, go take a look at that graph right there. Let me show you what other students have done. We're going to go back over here and show you what other students have done. So, this person's birthday graph, if you notice, they have their graph is right here, but when they saw their graph, they saw a roller coaster. I'm sorry, not a roller coaster. They saw a butterfly. I don't know where I got roller coaster from. They saw the antennas of a butterfly, and so they were able to adapt that way, right? This next person, here is their birthday graph. They have something that looks like this. And what they did was they decided to use this as the top part of their little monster here. This part was part of their webbing, and this kind of like connects with the tail. Okay. For this one, I think their graph goes like right here. Kind of looks like the body of this character right here. Or I think it's from Invincible, if I remember correctly. This point person decided to make their stuff look like the coins that Mario would go and collect. So there's many, many different things that you can do, right? It's just your imagination. This looks like the rock that Ariel's sitting on. And the last one we have is someone's spider web, right? So they use this to kind of create their spider web. So there's many, many things that you can come up with. Be creative with it, but see what kind of picture that you come up with. Now, mine, if you remember correctly, I think it did something like this. I don't remember exactly, but it's something like that. Actually, let me take a look. I don't want to lie to you, and you tell me like, no, that's not what happened. Let's see, what did it look like? Oh, I have the thing going the other way. Okay, so it starts. It looks like an even function with a mini hill. So we said even function with a mini hill. I think it looks something like this. And the first thing that I saw when doing this, me and my wife love to go on roller coasters. We love to go to Disneyland. So the first thing I thought of was like me and my wife here on a roller coaster. Okay, now look at this picture. This picture took like 3 seconds to do, right? It's not going to get a good grade. I showed you the other pictures. Those other pictures were amazing, and they could tell that they put a lot of time into it. So you definitely want to go off of something that looks like that to get the grade that you deserve on this. Okay, so now that you know how to come up with your graph and you're going to come up with your own picture, let's talk about some of these other things that I want on your graph. The one of the things I want is obviously the sketch. So my sketch is going to be like here. You're going to have your picture. Do what you got to do, right? My birthday, remember for me, was July 17th, 1982. And then the equation that I gave you guys earlier, you're going to write it right there. The domain means how far to the left and to the right does your graph go. In my case, my graph goes to the left forever and to the right forever. So my domain would be from -infinity to infinity. My range is how low and how high does my graph go? Well, there is a lowest value. I don't know what it is, but on your calculator, you can get it. My lowest value would be right here, right? Whatever that dot is right there, the y value of that dot. And I don't have a highest value. So I know it's going to be something to infinity. Let's figure out what that something is. So I'm going to go back over to my graph. This is why the setup is so weird, guys, because I got to be flipping back and forth. My lowest value is right here. Do you see it? Okay, I'm going to go ahead and click on that dot, and it tells me the y value. The y value was like -15.22. So I'm going to remember that -15.22. And then my y-intercept is right here. I can go ahead and click on that dot, and it tells me 0,2. So -15.22 is my minimum. So let's see, this is going to be from -15.22. And because it actually reaches there, I really should be using a bracket there. And my y-intercept we set as 0, 2. For the x-intercepts, you're going to do the exact same thing. Remember that with Desmos, you can just click the dots, right? So you would click on this dot, this dot, this dot, and this dot to see where the zeros are at, okay? And then you would list those zeros here. Should be 4 different numbers. Your maximums are any y value, like any high points on your graph. Now, as far as an overall maximum, this thing goes up forever, this thing goes up forever, so there's no maximums there. But there is like a local maximum right here. So whatever the y value is right here, you click the dot and see what's the maximum you have for this local max. Local minimums are like a lowest point on your graph. You definitely have a couple of low points. You have a low point here, and you would look up the y value. And then you have a low point here, and you would look up the y value. Again, you just click it right there on your Desmos, and you would write your maximums and minimums there. End behavior, you guys are good with end behavior. It looks like 2 fingers pointing up, so my end behavior would look like this and like this. What does your creation mean to you? For me, it's a reminder of date nights with my wife over at Disney California Adventure or stuff like that, okay? And I believe that, oh, I'm sorry, the last thing you need, and I forgot to say, you need 10 different values here for your table. Now, this table right here, it sounds like it's going to be a lot of work. It is not, okay? Let me show you how to get the table from Desmos. Remember, everything is going to be done on Desmos pretty much, except for your final picture. So I don't want this one. Let me get rid of this one. I want to show a table as it relates to this graph right here. What you're going to do is you're going to hit on the little gear right here. You click on it, and then there's a table button. So you click on the table button. Notice that when I created my table, it already gave me the values, right? It's all looking pretty good, but I only have 1, 2, 3, 4, 5 values. I said that I needed to get 10 values. So if I want to get 10 values, you go over here, you click, and then I want the next value, which is going to be the value of 3. When I type in the 3, it automatically generates the number, which is really, really nice, okay? If I want to get the next numbers, really all I have to do is hit the enter button. Like I don't even have to hit 4, it'll just do it for me. And if I'm already at 4, if I hit enter again, I could get 5, 6, 7. So I can get as many values as I want. But remember, I'm not asking for all these. I'm just asking for the first 10. So I think this should get you up to 10 if I remember correctly. Okay, that's it. That explains the project. And if you have any questions, please feel free to ask.